Alright, so we're going to do trig angles. And before you even have to write anything down, let me just talk to you a little bit about what's going on. So if I have a unit circle, I'm going to try this and see how long it works. We've talked about lots of angles inside the unit circle. I'm going to deal with just one for right now. Let's say we choose, there's 3 points on here. I'm going to talk about the 60-degree angle. Right, we know that that's, and I know that I don't write it necessarily, but it's this angle right here is the reason we call it a 60-degree angle. Correct? But it kind of builds a triangle in a way. And what kind of triangle is this? It's a right triangle, right? And if you remember from from geometry, there was a little saying that everybody used when we dealt with right triangles called SOHCAHTOA. You guys remember that? Okay? SOHCAHTOA, right? And it helped us find sides. That's all it did, didn't it? Well, we are going to use that again in regards to the unit circle. Do you remember that sine of an angle, it's the reason we have SOHCAHTOA, is the opposite over what? Opposite over the hypotenuse. Agreed? Okay. Now, and then we would keep going, right? So cosine would represent, this is AH, meaning adjacent, and the H stands for what? The hypotenuse again. You all remembering? So that O is opposite, H is hypotenuse. And then we would say tangent of an angle. If you want to find the angle, you would just need, what's it say, O and A, so opposite over what? Adjacent. Okay, that kind of bring back some bells. Now, I'm just going to pick one. This is just kind of a demonstration. We'll take notes in a second, just so you understand what's going on. I'm talking about this angle right here. That green angle. And if I'm talking about that green angle, and I want to talk about the triangle. I know it's inside, I'm going to put this down so I can touch it. I know it's inside, there we go. I feel like I'm a magician. Alright, I'm going to try one last time. I'll never. Okay. So now I have this circle. Okay. My goal is to try to explain to you that whatever. So I have this triangle, okay? Please ignore the unit circle and let's talk about just the triangle for a minute. What I want to do is I want to tell you that if I'm talking about sine of this green angle, if I want to use sine of the green angle, it tells me opposite of hypotenuse. Okay, if I touch this side in green and this is blue, which side do you think when I'm using sine equals opposite over hypotenuse? Okay, opposite over hypotenuse. Which side do you think is the opposite of the green? The blue side or the green dot? Blue. Right, if I've got the green, if I've got this green angle, okay, this is considered the opposite side of the green angle. See how the sides opposite? So then, what about adjacent to that green angle? Which side would be adjacent to the green angle? The green dot. Right, so listen to what I just tried to say. I was talking about sine, right here. Sine of an angle is opposite over hypotenuse. Opposite over hypotenuse. So here's my green angle. If I'm talking about this green angle and I want sine, it's this side over this side. Right? Okay, yes?
Wouldn't the hypotenuse be the other side?
Yes. In fact, what's the measurement of this hypotenuse? In fact, we're going to get to that. Right, the measurement of this is 1. And now, okay, we're going to make a leap. We're almost there. This has an ordered pair that we've studied, short, long. So this is 1/2 root 3 over 2. Do you agree with me? Okay. How did I get this right here? We're considered to be adjacent, and it's the x value, which means this black line and this black line number go together, don't they? Right? And to get to that point, I had to go over 1/2 the x value. how do I get up? How high do I have to go? We'll use red. How high do I have to go here? Right, we went the y value here. So what I was going to try to explain to you is that here's my angle. The adjacent matches 1/2, right? The side across from it, or the opposite side right here, matches the √3/2. Are y'all picking that up? Okay. So what about, my question to you then is, in regards to the unit circle, the opposite is which value, guys? The opposite is the red, which is right, x or y?
Y.
The y, okay. And the hypotenuse in the unit circle is how much? 1. So what is, because it's such a special picture, because it's a unit circle, what is y divided by 1, guys? Y. So sine of theta is just y. Right? I'll do the same thing with cosine. Let's try cosine. Cosine is adjacent. Okay? Cosine of this green angle. Cosine is adjacent. What value is adjacent? X or y? X. Over hypotenuse. What value is the hypotenuse of this? What value is hypotenuse? 1. So cosine of an angle is x over 1. What is x divided by 1? X. So therefore cosine of an angle is x. Now guys, I'm talking about cosine of an angle in a unit circle, right? And this only works because what are we dividing by every time in the unit circle? 1, because the hypotenuse is 1. Okay? You gotta follow me or it's really gonna just go over your head. Alright? Now, last thing, tangent. I'm talking about tangent of this green angle right here. Right? So tangent is opposite. So opposite of this is what value? X or y? Is this the y or x right here? Am I going up or am I going left and right? This measurement is y. Okay. And adjacent, this is the adjacent, right? The x. Right, left and right is x, up and down is y. So therefore, tangent is y over x. We also call it, sometimes y is the same thing as sine. So we also call it sine over cosine. Okay? Now then, to put this in your notes, we'll start with that. Okay, so I erased it because now I'm just going to write it more neatly so you can have it in your notes because you're going to use it a ton. So we're doing trig functions of acute angles. The little saying that we talked about is SOHCAHTOA, right? And remember, the O is opposite, H is hypotenuse, and A is adjacent. Some kids mess up on that. It's SOH, SOHCAH, CAH, TOA. So it's SOHCAH. Now, we already learned then that sine of an angle is opposite over hypotenuse. Cosine of an angle then, cosine, look, AH, right? So where I'm getting that from? Adjacent over hypotenuse. And tangent is OA, which is opposite over adjacent.
I never clicked that that's what that did. Yeah, I thought it was just the same. I hope it remember.
Oh, yeah, and that's where they come from.
That's awesome.
Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Do you get it? Perfect. Okay, now I talked all about that, but I didn't talk about what we call the reciprocal functions. So reciprocal means we're going to flip, right? Okay? And so if you remember SOHCAHTOA, you're good to go. So the easiest reciprocal is tangent. Reciprocal of tangent is cotangent. Easy, right? In cotangent, if it was opposite over adjacent, what's it going to be now? Adjacent over opposite. Okay? Now, cosine, the reciprocal cosine isn't as easy to remember. It's secant. And that is, if it's adjacent over hypotenuse, it's hypotenuse over adjacent. All you have to know is SOHCAHTOA, because you can fill in the rest. The reciprocal of sine is cosecant. Okay, which is hypotenuse over opposite. Okay, now, hang on. I have one more thing to explain to you. Sometimes, since sine and cosecant go together, it's called cosecant, okay? Since they go together, another way people write it is just this. Cosecant of theta is just 1 over sine. And they say, okay, secant of theta, what do you think that would be? If cosecant is 1 over sine, secant is 1 over, good. And then what's tangent going to be? I'm sorry, cotangent. Cotangent is going to be 1 over tangent. It's a lot, I know. Alright, so listen to the reciprocals again. This reciprocal of tangent is the easiest. Tangent goes with what? Cotangent. The more you say it, the faster you'll learn it. The reciprocal of cosine is secant, and the reciprocal of sine is cosecant. Okay? Those are the reciprocals, and the reciprocal just means they're flipped. Okay, so moving on, we kind of already talked about this in your notes, so you've already are on the screen. But let's add it to our notes so we have it. If we're talking about a unit circle, in other words, the sine, cosine, and tangent, when it involves a unit circle, is special because the hypotenuse of a unit circle is 1, right? So all these where you're dividing by the hypotenuse, you get to just keep the top. So it makes it super easy. So if you're talking about a unit circle, we'll use the same angle as before. Okay, and remember we talked about cosine of theta is the adjacent over hypotenuse, right? It's the CAH, cup, or cat, whatever, however you can remember it. So SOHCAHTOA, I guess. Okay, here is your angle. In order to get to this point, you watch me if you didn't understand earlier, I have to travel an X amount, and then to go up high, I've got to travel a Y. So this ordered pair is considered X, Y. We all see how I got to the ordered pair. So for cosine, the adjacent of this pink angle is X or Y. Which one is adjacent to this angle?
X.
Right next to X. Which means I want X over my hypotenuse, and hypotenuse is 1. So that's why we know that cosine of theta is just X divided by 1, or X. Isn't that cool? It's because you're dividing by 1. So adjacent over hypotenuse, X divided by 1 is just X. So cosine on the unit circle is X. So when you get to this point, guess what? Whatever this is cosine. Okay? Now go to sine. Sine of theta, the little, is OH, right? Opposite over hypotenuse. So if you have this angle right here, which one's opposite? Okay, so Y. And what's the hypotenuse in the unit circle? 1. Y divided by 1 is Y. So sine on the unit circle is Y. Well, if sine is Y, look at this right here. Here's my y, so this is sine. So in your ordered pair, you can look. I'll show you. Okay, so we're talking about this point right here. This is sine. I'm sorry, this is cosine, 1/2, and sine is root 3 over 2. Because this is the x value, short. It's the long value. Now, what's the last one? Sine, cosine, and so tangent of theta is just opposite over adjacent. So katoa. Look at your unit circle. Oops, I went too high. Opposite of pink is y. Adjacent is x. Adjacent is always x. So tangent is just y over x. Or sometimes they'll call it sine over what? Cosine. Sine is x. I'm sorry, cosine is x. Now, take your unit circle out for me. Let's do a couple examples. Look at your unit circle and see if you can find the value of cosine at 30 degrees. You're going to look at your unit circle. You're going to go to 30 degrees, which is this stop right here. And you want cosine. What do you think it is? Remember, this is the x and this is the y. Cosine is x and sine is y. I always tell my kids it's alphabetical order. X, y, C, S. They're all in alphabetical order. Does that make sense? So what's cosine for 30 degrees? Yeah, excellent. It's the x value. In other words, that traveled really long. Here's my right triangle, guys, right? Cosine is adjacent over hypotenuse. So the x value in this is root 3 over 2. So root 3 over 2 divided by 1 is just root 3 over 2. Do you see it now? Okay. So this is root 3 over 2. Go to sine of 100 and 20. Sorry. Sine of 120. Sine is the y value. So if you're starting here, you're trying to get to 120. This is cosine and sine. What's the sine value? Root 3 over 2 as well. Okay, I'm going to try to really throw you off by asking you for tangent of 180. Tangent is opposite over adjacent, or we call it y over x. Find tangent at 180. Find 180 on your picture, on your unit circle. Okay, what do you think it is? It's the formula calls for y over x. Right, so x and y, so 0 over negative 1. What is 0 divided by negative 1? Be careful, I heard it.
0.
Yeah, it's 0, remember? So 0 over negative 1 equals 0. Okay, we're about done for today. I'm going to let you write in the directions, and we're going to stop. We're going to write the directions and stop. We'll learn how to do it tomorrow. Find the 6 trig, write the directions, functions of an angle theta in standard position. Passing through 8, 6. So that 8, let's do 8, 6, guys. Okay, and then we'll finish tomorrow.